Welcome to Building a Financial Model Part 1. By the end of this session, you will be able to apply a structured approach to financial modeling in Excel, outline the hallmarks of good financial models, and explain the importance of planning your model structure. You will also forecast an income statement from operating revenue down to operating profit. Let's get going.
Let's start with the importance of applying a structured approach to model building. If you break apart a robust financial model, you will typically see the same core building blocks. Robust models clearly separate inputs, processing, and outputs. Financial models should have inputs clearly identified and separated, and allow for inputs to only be entered once. The processing of inputs into outputs should be transparent and broken down into steps that are easy to follow. Outputs should be organized so that users can quickly access the outputs they wish to see or use. Because of their importance, we'll explore each of these fundamental building blocks in more detail. Before we examine the building blocks, it's important to stress that model building is not an iterative process. Models built on the fly typically contain errors. In order to minimize errors when building your financial models, consider the following 5 steps. First, clarify the business problem. What problem is this financial model meant to solve? Who are the end users? What do users need to be able to do with this model? Second, think about all inputs and outputs needed. Try to keep the model as simple as possible. Ask yourself, what are the minimum number of inputs and outputs that we can get away with and still have a useful model? Third, plan your model structure, including how the inputs, processing, and outputs will be laid out in your model. If possible, try to keep your inputs all in one place. Fourth, once you've created your model, consider Excel tools that will help protect the integrity of your model, such as data validation and conditional formatting. Finally, consider using test data to check that your model works as expected. The second point we referred to on the previous screen related to simplicity. Think about a financial model that you have recently built or used. How large is the model? Is it less than 1 megabyte or more than 10 megabytes? There is an inherent tension in model building between making your model realistic and keeping it simple and robust. Large models may appear to offer users a high degree of detail and precision, but by their very nature are harder to follow and audit. Small models are generally easier to follow and audit, yet lack the degree of precision necessary for decision-making. The best financial models work to reconcile these opposing forces, keeping things as simple as possible while still providing sufficient detail for decision-making. Now, let's look at those financial modeling building blocks, the inputs, processing, and outputs in more detail. When building the input section of your financial model, it's important to consider how your model ensures that inputs are accurate, inputs remain within reasonable data ranges, and that inputs are easy to use, understand, and update. Your model should be structured so that data is only ever entered once. Your inputs also should be clearly highlighted with color so that they are easily identified. Yellow shading or blue font color are often used for model inputs. The models you will see in this course always have inputs shaded in yellow. Finally, consider using Excel tools such as data validation, conditional formatting, and comments to help you maintain the integrity of your model inputs. Let's explore how Excel's data validation tool can be used to enhance the integrity of your financial models. In Excel 2007 and later versions, data validation is found on the Data ribbon under Data Tools. The data validation window has three tabs: Settings, Input Message, and Error Alert. In this screenshot, the gross margin input range has been set to between 0 and 90%. Although you cannot see the Error Alert tab, it has been set to give the user a warning message if gross margins are set outside this prescribed range. In Excel 2003 and previous versions, data validation is found on the Data menu. If you put data validation on your model inputs, you can check if a user has set inputs to numbers outside the preset data validation ranges. To circle invalid data in Excel 2007 and later versions, go to the Data ribbon, Data Tools, Data Validation, and then circle invalid data. In Excel 2003 and previous versions, go to View, Toolbars, and then Formula Auditing. Okay, let's see data validation firsthand in Excel. For this demonstration and throughout this course, we use Excel 2007. In 2007, data validation is found on the Data ribbon. In 2003, data validation is found on the Data menu. Before selecting data validation, use your cursor to select the cell that has the gross margin input. On the Data Validation window, go to the Settings tab. Here, the validation criteria will be set to allow a decimal. We then set the data box to between, the minimum to 0, and the maximum to 0.9. We then go to the Input Message tab. In the title box, we will type "Please note." In the Input Message box, we will type "Please input your assumption for gross margins. Historically, gross margins are between 0 and 90%. On the Error Alert tab, we will set the style to Warning. We'll set the title to Warning. And we will put an error message that reads, "You have input a gross margin assumption that is not between 0 and 90%. Once finished, click OK. To test whether the error message is working properly, we can type in 95% into the gross margin input. When the error message appears, click Yes to continue. We then know it is working correctly. Now we can use the Circle Invalid Data tool to find the input that is set outside the prescribed ranges. In Excel 2007, this tool is found right next to data validation on the Data ribbon. In Excel 2003, you will need to make the Formula Auditing toolbar visible as explained previously.
Now it's your turn. Click on the attachment link entitled Data Validation Exercise with Instructions. Once you've had a go, check your attempt with the attached data validation solution. Good luck!
Now that we've covered inputs, let's consider how to translate inputs into outputs. Do you try to put all your processing calculations into as few cells as possible? Do you hide your processing cells or worksheets? If you do, then you may already know that hiding calculation cells or putting too many calculations into a cell makes your financial model harder to maintain and also harder to audit. Ideally, you want your processing calculations to be easy to maintain, structured to ensure accurate processing, and above all else, transparent so that users understand how the model works. Where possible, break down complex calculations into several steps. Use comments to explain how your financial model works. Use formatting to ensure that formulas are not accidentally overtyped. And finally, calculate final figures on your processing worksheets and then link these figures to your final output sheets. This will make your model easier to follow and audit. Ideally, you want to make sure your output cells or worksheets are easy to understand and unambiguous. Consider making your outputs modular so that the end user can choose which outputs he or she wants to review. For example, put your income statement forecast, balance sheet forecast, and cash flow forecast on separate worksheets rather than all on the same worksheet. Consider creating a summary output sheet that allows users to review the key model outputs without having to go through the entire model. Use color to inform the user that your output cells are formulas and should not be touched. Finally, consider protecting your output cells and worksheets in order to maintain model integrity. Let's talk about how to protect cells and worksheets. The first thing you should know is that the default setting in Excel is for individual cells to be locked. When a worksheet is protected, this default setting means that all cells will be locked down. Although your model's output cells should be locked, input cells need to be unlocked before protecting a worksheet. The Excel shortcut to unlock cells as well as format cells is Control-1. The Format Cells window has a separate Protection tab where you can lock and unlock individual cells. In Excel 2007 and later versions, once you've unlocked your input cells, you then protect your worksheet by going to the Review ribbon, Changes, and then Protect Sheet. In Excel 2003 and prior versions, you can protect your worksheet by going to Tools, Protection, Protect Sheet. Now that we've explained the context, let's demonstrate how locking and unlocking cells and protecting worksheets actually works in Excel. Although we are using Excel 2007, the shortcut for formatting cells is the same in all versions of Excel. It is Control-1. First, we need to highlight the cells to unlock. These are the three input cells highlighted in yellow. Then, by pressing Control-1, we access the Format Cells window. We need to toggle to the Protection tab. We need to ensure that the Locked button is deselected. If it is selected, make sure you deselect it, and then click OK to return to the spreadsheet. Now we need to lock down the worksheet. In Excel 2007, we go to the Review ribbon, Changes, and find Protect Sheet. In Excel 2003, remember to go to the Tools pull-down menu. For this example, we will leave all the default settings and not set a password. Passwords are optional. Once OK is selected, all cells should now be locked except for the 3 input cells that were unlocked.
It's your turn again. Click on the attachment link entitled Protecting Data Exercise with Instructions. And once you've had a go, check your attempt with the attached Protecting Data solution. Enjoy!
Now that we've covered the building blocks, let's talk about actually building a financial forecast model. Over the next 4 sessions, we will build a complete set of financial statement forecasts, starting with the income statement. In this module, we're going to work on forecasting the income statement down to operating profit, or EBIT. Once we have completed this step, we will move to the balance sheet where we will forecast operating assets. We will then forecast finance, which has implications for both the income statement and balance sheet. Finally, we will derive a cash flow forecast. The first step in our model building case study is to forecast revenues down to operating profit, or EBIT. We will stop at this point because after EBIT comes financing costs, which will depend in part on what we are forecasting for our operating assets. Earlier in this session, we talked about the inherent tension in model building between making your model realistic and keeping it simple and robust. The first principles approach outlined here identifies how you would go about modeling revenues if you need a high degree of detail and precision. The quick and dirty approach outlines how you can model revenues in a much more straightforward way, with the benefit that your model will be smaller as well as easier to follow and audit. For our case study, we are going to use the quick and dirty approach, using historic figures and trends to predict future revenue growth. After forecasting revenues, we next want to forecast gross margins. Gross margins are usually forecast as a % of revenues. Again, you can use historic figures or trends to quickly forecast future margins. However, you may need to consider a more detailed approach, which considers the cost of inputs as well as factors such as economies of scale and learning effects. This second approach will make your model more realistic, with the trade-off being that it's more complex and somewhat harder to follow. The next step would be to forecast overhead costs. Forecasting overhead costs such as selling, general, and admin costs, or SG&A, is often done as a % of revenues. Although these costs are fixed over the short term, over the longer term they are more variable. This allows us to link them to revenues. For forecasts over shorter periods, like weeks or months, using revenues to help forecast SG&A may not be appropriate. Some models forecast gross and operating profit margins and leave SG&A as the balancing figure. Okay, it's time to demonstrate how building the income statement forecast can be done in Excel. The first thing to note is that all the forecast inputs are on the same worksheet entitled Ratio Drivers. By keeping the inputs on this separate page, we keep the model simple and easy to update. Our inputs should only be ever entered once. This model also has separate output worksheets for the income statement, balance sheet, and cash flow statement. There is also a notes worksheet where detailed processing calculations for PP&E and equity are broken down in order to make the model easier to follow and audit. In this demonstration, we are only working on the ratio drivers and income statement worksheets. Starting with the ratio drivers worksheet, you will note that all of the income statement input assumptions down to EBIT can be found in rows 8 through 14. All of the expenses are being forecasted as a % of revenues. Only sales is being forecast based on growth over the previous year. The inputs on the ratio drivers worksheet are also ordered in the way they will appear on the income statement. Now let's move to the income statement worksheet. We are going to work in column D and work downwards. To forecast revenues, we take the previous year and grow it by the assumption on the ratio drivers page. The formula in D6 should read equals C6 times open bracket 1 plus ratio drivers D8 close bracket. We can now move on to cost of goods sold. This is going to be forecasted as a percent of our forecast revenues. The formula in cell D7 should read equals minus D6 times open bracket 1 minus ratio drivers D9 or forecasted revenues close bracket. We can then sum the two to get gross profit. A shortcut for summing is Alt equals. We will then move down to the other operating expenses, which are also forecasted as a percent of forecast revenues. The formula in cell D9 reads equals $D $6 times ratio drivers D10. The dollar signs are there to lock the referencing of forecast revenues so that it is an absolute rather than relative reference. Because we have done this, we can then copy the formula down. A quick way to copy formulas down is to highlight the area where you want to copy to and then just go Control D. The final thing we need to do is sum up gross profit and all the operating expenses. We can do that with Alt equals. And we are done. The number you should have for operating profit or EBIT is 6518.
Now you have a go. Click on the attachment link entitled Forecast Part 1 Exercise. Once you've finished, check your result with the attached Forecast Part 1 solution. Have fun.